So it asks us to draw the following segment after a 90-degree counterclockwise. I put a little arrow here, counterclockwise rotation about the origin. Counterclockwise is our normal rotation, so just a positive 90 degrees. I've drawn in the portion of the x-axis here. I'm also going to draw in the portion of the y-axis just so that we can see how this thing moves. We're going to rotate it. We want this whole portion. This is basically, this quadrant 4 is now going to become quadrant 1. So I'm going to label this quadrant 4. And this up here, quadrant 1. And that's what we want to do, is we want to just rotate this thing 90 degrees. So this line is going to come up and become the new y, the positive y-axis, and this is going to rotate up and become the new positive x-axis. And we're just going to take this thing and rotate it so that it's going to look the same. The line segment is going to look the same. It's going to be constant in proportion to and relative to this line and this line. However, those lines are going to change. So if we go ahead and put down our tracing paper here, and I'll go ahead and draw in this y, this negative y-axis as well. Let's look to see what happens when this thing rotates. So here's my pivot point about the origin. We see that it's about the origin. That just means that that's our pin. We put our pin in and it pivots around. It pivots around. So as we move, we're moving 90 degrees, which is a quarter of a circle, which means that that fourth quadrant is just going to go up and become the next quadrant up there, which is quadrant 1. And as we rotate it, we see that the line, again, the line is going to look the same relative to these two lines that we've drawn, the axes. Okay, it definitely has a different positioning on our normal quadrant, but relative to the lines that we drew in, it looks the same. That's why I like to look for kind of landmarks. So I see that it's crossing here real close, only 1 unit away. Here we still have 1 unit away. So nothing happens to the line, and we can use our formula here that says that when we rotate 90 degrees, when we're rotating 90 degrees about the origin, well, our xy coordinate now becomes a negative y, positive x. What that means is whatever value we have for our original point in the y will become our new x value, but negative. It looks like I've come off the page. So let's say it becomes negative y x. So what does that mean for us? Well, this original drawing right here, and I'll draw it on top of the tracing paper so you can see, it looks like we have an x equals negative 1, and then a negative 1, 2, 3. This here is a negative 1, negative 3. And this point here is a positive 4 and negative 5. Positive 4, negative 5. So I'm going to go ahead and pull that to the side now. I'll write these down. Negative 1, negative 3, and a positive 4, negative 5. Those were the points of our line segment. So how can we draw it without having trace paper? How can we draw it on here? Well, we can label them just like we did, and we see that we have a slope here of negative 2 down 2, and then we're going over 1, 2, 3, 4, and 5. So we're going to have a triangle that looks like that. So here's our points, and our formula says to go from xy to negative y x. So if this is our xy, then we want to make our new xy coordinate. The value of x is going to be the same as y, but the opposite sign. So a negative 3 will be a 3, and then just the same x value, but in the y place, so negative 1. So notice how it flopped there. And then we'll do the same for this next point. We would want the negative y value, so a negative 5, which would be a positive 5, but in the x place. And then the x value of the original will go in the y place. So we can go ahead and graph that. And that's a positive 3, 1, 2, 3, negative 1. And then a positive 5, 1, 2, 3, 4, and 5, and up 4, and 4. And then we would draw our line in between. And we see it has the same general, the same slope, kind of a sloppy line there, but there's our new segment. The slope obviously would be different now because what was the horizontal shift is now the vertical shift, but the triangle is congruent.